Going to begin with connectivity utilities defined. Before we can define the utilities, we need to define connectivity. Connectivity is a program or device's ability to connect or link to other programs or devices. A connectivity utility is a utility or application that is used to establish connectivity and or to diagnose or fix a connectivity issue. With that out of the way, let's move on to connectivity utilities explained. All modern operating systems come with pre-packaged connectivity utilities designed to diagnose and or to repair connectivity issues. In some cases, you can use these utilities or programs from a graphical user interface or GUI. However, in all cases, you can use the following applications from the command prompt. First up is ping. It is a simple utility that is used to determine if there's connectivity between two nodes or two endpoints. It uses ICMP echo requests. There are two basic formats to the ping utility. You can ping an IP address, or you can ping the host name or the fully qualified domain name. You can use ping 6 or ping -6, and you will ping only IPv6 hosts. Then there is tracert or traceroute. It is a utility that is used to determine the path used between two nodes. Tracert, T-R-A-C-E-R-T, is the Windows version, and traceroute, T-R-A-C-E-R-O-U-T-E, is the Linux, Unix, or OS X version of the command. It also uses ICMP echo requests, but it uses it with an incrementing time to live field to form queries and get responses. Each time the ICMP echo request is sent out, the TTL field is incremented by 1. And tracert is used to determine how many routers are between 2 points. It can be of limited value though, as many routers have ICMP disabled. It uses the same basic format as ping. Then there is pathping. It is a network connectivity utility that has been supplied in Microsoft operating systems since the introduction of NT. Pathping built upon the functionality of ping by combining it with tracert. When the application is used, it will, in effect, perform a tracert command, defining the path to the end node, and then it will perform a ping test on each hop. One disadvantage to pathping is that it requires 25 seconds per hop to show the ping results, and it uses the same command format as ping and tracert. One of my favorite utilities is ipconfig or ifconfig. ipconfig is the Windows version and ifconfig is the Linux, Unix, OS X version. It's used to determine the IP configuration of a given node. It can also be used to change that IP configuration if used correctly. When using to diagnose connectivity, look for incorrect IP addresses, incorrect subnet masks, incorrect DNS addresses, and or an incorrect default gateway. Then there's ARP, which stands for Address Resolution Protocol. ARP is used to correlate IP addresses to MAC address. This utility can help to determine when there is an issue with an address resolution protocol table on a given node. Then we have nslookup. That stands for Name Server Lookup. It's supported by all major operating systems, and it's used to diagnose domain naming system issues or DNS issues. It can be very helpful in determining if a DNS server is having a problem. DIG is similar to nslookup, but it is specific to Unix, Linux, and OS X. It does use different switch modifiers and returns slightly different results. There is the route utility. This is a Windows-specific command. It's used to view and modify the routing tables on a Windows operating system node. Next up is nbtstat, which stands for Net BIOS over TCP Statistics. Windows implements the NBT protocol for backwards compatibility. As a result, The nbtstat utility is used if a NetBIOS issue is suspected. Then there's netstat, which stands for Network Statistics. It's a utility that is used to display protocol statistics and current TCP/IP network connections. It's useful for determining if a connection has been made and the status of that connection. It's time to move on to some additional software. First up are throughput testers. They're used to determine the data flow or bandwidth of a network. They can be used internally to test the flow or bandwidth within a local area network, or they can be used externally to test the flow of a WAN connection. They are often used to create a baseline of network performance. And last up, we have protocol analyzers. These are often called packet sniffers. They examine network behavior on a very basic level, at the packet level. They can examine all the packets coming into and out of an interface. Protocol analyzers are useful to see what is consuming network resources, as in they can tell if a broadcast storm is occurring or if an interface is going bad. Wireshark is a common protocol analyzer that is often used, and it's free. We will begin with what makes a cable bad. Network cables can go bad or be bad without any visible indication. Alternatively, a cable may be inappropriate for a particular application. It can be difficult to visually tell if cables are wired correctly and/or a break in the wire may not be visible. Both of these will cause problems. Additionally, anything that makes the cable fall out of specification will make it a bad cable. How long is the cable? Is it over the maximum length? Is the cable rated for the amount of data being run over the wire? All of these are questions that can be answered using the proper tools. It's time to discuss cable testing tools. First up is the multimeter. It can be used to test for breaks in copper wiring. Good network cables have a very low resistance value from one end of the cable to the other. By the way, your resistance is measured in ohms. A high or infinite ohms value indicates a break in the cable. So you can use multimeters to test for continuity to make sure that traffic can flow from one end to the other. Crimpers are not a testing tool per se, but they are used for attaching cable ends onto cables, which if you suspect you have a bad cable end or a miswired connector, you're going to need a set of crimpers. It can either be specific to a particular type of cable end, or it may work for more than one type of cable. And by the way, it's not uncommon to need to replace the ends of twisted pair wiring cables. Every network technician should have a cable tester or cable certifier. These can be either fairly simple or very complex. Cable testers will test for continuity in the wire, as in, is there a break? Cable testers will also test for proper pinouts. Are all the wires in the right places? Some will test for the wiring standard. Is it wired for the T568A standard or the T568B standard, or have you created a crossover cable? Cable certifiers are a little bit more complex, but they will also test for more network-related items. They can test the speed of the wire. They can test for duplex settings between two endpoints. Cable certifiers are used to certify a given network segment. Toner probes are another handy tool. They are usually a two-piece set. They have an injector which places a signal onto the wire and a probe which detects the signal and emits a tone when it detects that signal. These are also sometimes called a fox and hound. They're used to find and trace wires. They're useful when having to replace a single wire in a bundle of wires. You can place the injector on one end to figure out which wire it is at the other end. Then there is the time domain reflectometer. This is a cable tester or certifier that can also determine the length of a segment. They can also tell where a break is in a segment, which can then allow you to put in a splice. They are more expensive than a standard cable tester or certifier. Related to the TDR is the optical time domain reflectometer, or the OTDR. They perform the same function as a TDR, but it is used for fiber optic cabling. It is often called a light meter, as it can measure the quantity and quality of the light going through a fiber optic cable. Some other thoughts on cable testing tools. Unless your job entails mostly installing cabling, the most important tools are the cable tester, crimper, and toner probes. Personally, I have never been able to justify the cost of a TDR. I have used them, but I've rented them instead of purchased them. Most of the time, you can make do with inexpensive tools. However, spending more on certain tools will usually save time and money in the long run. An exception to the inexpensive tool rule are toner probes. Inexpensive toner probes can be difficult to work with, or they just don't work at all. I would recommend stepping up and spending a little bit more for your toner probe. Try to strike a balance between cost and effectiveness. You can spend thousands of dollars on some of these tools, especially TDRs and OTDRs, and never utilize them to their fullest potential. The next topic is additional tools. And we will begin with the wireless analyzer. It is a similar tool to the protocol analyzer, but it is used for wireless networks. It sniffs out packets on wireless networks. This information can be used to help solve wireless connectivity issues. A wireless analyzer can also perform other functions. It can check for bandwidth usage, channel usage, top talkers, and top listeners. It can identify networks by passively scanning the radio frequency channels. It can identify hidden networks if given enough time, and a wireless analyzer can also infer non-beaconing networks based on data traffic, so it can help you to find those rogue access points. Then there are looking glass sites, or LG sites. These are publicly available sites that can be used to view routing information remotely, as viewed from the LG server's point of view. They create a read-only portal on which routing statistics can be generated and viewed. LG sites can be helpful in determining if the connectivity issue is occurring because of problems on the local network or if the remote connection is the issue. That